Hello my dear students, once again welcome to your online class. So today in this video we'll be discussing about the second part of current electricity, that is the electrical power and the energy. Now we categorize this electricity as energy because we know that the electrical energy is capable of doing various kind of work. The electrical energy can be converted into many other forms of energy. So we have already studied from the conservation of law of energy that the energy can neither be created nor it can be destroyed, but it can be converted from one form to the another form. So similarly, using electrical energy we can obtain various other forms of energy. So you can see it in your house as well, like using electricity we can cook food, that means the electrical energy can be converted into heat energy. Using electricity we can move a fan, so that means the electricity can be converted into the mechanical energy as well. And also we glow the bulb in our houses, so that means the electricity is capable of being converted into the light energy as well, and various other forms like a sound and many more. So the electrical energy is capable of doing work, so that's why the electricity is termed as energy. Now the question comes, how to measure this electrical energy? So to measure the electrical energy we may begin with the definition of the potential difference. So I have already taught you that the potential difference is the work done per unit charge. Okay, so I may write the formula V is equals to W divided by Q. So if I cross multiply this expression, I will get W will be equals to V into Q. So this is the first expression to measure the work done, that means the potential difference into the charge. So this is the first form or the first formula to measure the electrical energy or the work done by the electrical energy. Now since I know that current is equals to, it is Q divided by T. So what can I do? So from this expression I will get Q is equals to I into T. So substituting this value in equation 1, I will get W will be equals to, now for the value of Q I will write IT. So I get V I into T. So this is the second expression to measure the work done by the electrical energy. Okay. So now there are, apart from these two standard form, there are other forms of equation to measure the electrical energy or the work done by the electrical energy. So how do we obtain that? So from the Ohm's law. So from the Ohm's law we have the expression V is equals to I into R. So substituting the value of V in equation 2, I will get W will be equals to, now instead of V I will write I into R, okay, and then again I T. So simply I will get W is equals to I square R into T. So this is the third expression to find the work done by the electrical energy. Now we have one more last expression to find the work done by the electrical energy, and how do we obtain? Again implying the Ohm's law here. Now since I know that, since V is equals to I into R, so I try to replace the value of I there. So I will be equals to V divided by R. So substituting this value of I in equation 3, so what will obtain? I will obtain W equals to, now instead of I will write V divided by R square into R into T. So this will give me W equals to, now V square, now this square and R get cancelled, so it will be R into T. Okay, so this is the fourth expression to calculate the work done by the electrical energy. Okay, so is that clear? So now coming to the second one, second term, that is the power. Okay, so we know that the power is the rate of doing work. Okay, so we know that the power P is equals to, it is W divided by T. So how do we obtain the expression for the power? So each of these four equations I will divide it with T. So the expression thus obtained is simply the expression for the power. So first one, so the first equation for the power I will get P equals to W divided by T. That means I will divide this expression by T. So I will get VQ divided by T. And in the second, what will I do? Second, here I have again the P will be equals to dividing this expression by T, T and T get cancelled, and I will get V into I. Now the third one, so in this expression I will divide with T, again P will be equals to I square into R, and finally the fourth one, so here, so dividing this by T I will get P equals to, so T and T get cancelled, I will get V square divided by R. Okay, so thus very easily I get the four expressions to find the power of an electrical energy. So that is how we obtain the expression for the work done by the electrical energy, or simply the E and the power, that means the rate of doing work. So now coming to the second point, that is the SI and the commercial unit of electrical energy. So how do we obtain? Now we know that the SI unit of power is watt. Okay, so if I want to find the SI unit of power, so simply from this the work is measured in terms of joule and time is measured in terms of second. So joule per second is the SI unit of power, which is usually termed as watt. Okay, so using this concept of watt, we can find the commercial unit of electrical energy. Now coming to the SI unit of electrical energy is simply a joule. Okay, because the energy is also the capable of doing work, so the SI unit of electrical energy is joule. But this joule cannot be used to measure the energy that we consume in our houses. Okay, so that's why the unit that is used to measure the amount of electrical energy consumed by the peoples or the humans are known as the commercial unit of electrical energy. So how do we obtain? We obtain by the expression. So we know that the power is equals to, it is the rate of doing work, W divided by T. So if I cross multiply this expression, I will get W will be equals to P into T. So from this expression I will obtain the commercial unit to measure the electrical energy. So the power is defined as watt, and then the time it is measured in second. So watt second is the commercial unit of electrical energy. So now apart from this, there are other higher units of commercial unit. Okay, that means we measure in terms of, so another we have is the watt per hour. So it is watt per watt hour, or also we have kilowatt. Okay, we write kilo, it is kilowatt hour. So now to define each of these, okay, so it's very simple how to define. So watt per second, or not watt per second, watt second. So how much is this energy? Any device which is rated 1 watt, and if it is used for 1 second, then the electrical energy consumed by that device is said to be 1 watt second. So usually the device which we use in our houses, we do not use it for a second. Maybe we use it over an hour. So that's why the bigger units are the kilowatt hour and the watt hour. So watt hour, what does it mean? It means that any device which is rated 1 watt, and if you use that device for 1 hour, then the electrical energy consumed by that device is said to be 1 watt hour. Similarly, the kilowatt hour can be defined as, it is any electrical appliance which is rated 1 kilowatt, and if it is used for 1 hour, then the electrical energy consumed by that device is said to be 1 kilowatt hour.